Nonetheless, I'll go on mute.
Okay. Hello, everyone, and welcome to Kubernetes Trials and Tribulations in the Cloud, Data Center, and Edge. This is brought to you by the SNIA Cloud Storage Technology Initiative. Today's conversation is with Michael St. John, Senior Principal Marketing Manager with Red Hat Hybrid Platforms. Hello, Michael. How are you?
I'm doing well today, Michael. How are you doing?
I'm doing great. Awesome. Next, we have Pete Brey, Global Product Executive with IBM. How are you, Pete?
I'm doing great today. Looking forward to our session.
Awesome. Yeah, sounds good. And I'm Michael Hoard, your host and facilitator for today's discussion. I work for Intel, and I am co-chair for the SNIA Cloud Storage Technology Initiative. Before we get started, I want to mention that SNIA, the Storage Network Industry Association, is a group of about 180 industry leading organizations comprising of 2,500 active contributing members and 50,000 participating IT end users and storage experts worldwide. As one of the organizations within SNIA, the Cloud Storage Technology Initiative is dedicated to education and promotion of cloud storage technologies like Kubernetes, as well as driving understanding and collaboration among other industry associations. So let's see. So before we get started, let's take a quick look at the SNIA legal notice. This provides SNIA's copyright notice regarding use of the material. There are no warranties expressed or implied, so if you want to reference the material, please do so at your own risk. You can download a copy of this presentation using the interface in this live webinar. The interface also allows you to submit questions during the talk and rate the presentation at the conclusion. We really appreciate your questions and feedback. So for today's discussion, Michael and Pete will first share a few slides to describe some of the current challenges around Kubernetes, including cost, security, data gravity, and extending workloads to the edge. Then we'll have an informal conversation on a few topics listed here, and we hope you in the audience will submit questions to our experts. If we're not able to cover all the questions during the session, we'll answer your questions in a Q&A blog, which will be posted after the webinar. So with that, Michael, take it away.
Yeah, thanks, Michael. I just thought I'd start off by discussing some of the trends that we're seeing in Kubernetes adoption. We can talk a little bit more about what it means for people adopting containers and how cloud-native storage is being consumed and accessed by these applications as well. And I invite yourself and Pete, of course, to interject, and we can talk a little bit through each of these slides. But just to kind of have like a jumpstart point or place where we can start the discussion, I thought it would be good to level set. So, first of all, when we look at the current state of application delivery, most enterprises today have a mix of modern cloud-native applications and legacy apps. A lot of the large enterprises, they have a huge portfolio of existing apps that are built with traditional architectures and traditional languages. Think of things like Java or .NET or even like C++, or I bet you there's still some COBOL out there as well. And these are supporting both stateless and stateful workloads. But in addition to this, many folks are building new applications or modernizing some of those existing apps on new architectures like microservices, APIs, and also utilizing different languages and frameworks like Spring or Quarkus, right? And so we're seeing more and more interest in building more intelligence through analytics and AI/ML as well, or even automating workloads through distributed event-driven architectures and serverless functions and things like that. So, as folks are modernizing these applications, a lot of questions come up around when and how to transition existing applications, and how do they integrate with their business processes, and what development processes and methodologies are they adopting, right? So are they using an agile or waterfall methodology? Are they starting to adopt things like CI/CD pipelines and GitOps to operationalize the workflows and create a continuous application lifecycle? And then, of course, where are they running their applications? Are they running it in the cloud? A big push over the past decade about adopting cloud. Do they still have applications running on premise, on bare metal servers and virtual machines, et cetera, et cetera? And what we're seeing is that organizations are doing all of this. Many are already using multiple clouds in addition to a private cloud or data center type deployment. And a lot of folks are used to running virtual machines, and they're trying to figure out if they should just run containers on top of existing virtual machines, or if they move to bare metal. And can they move more of their processing out to the edge as well? That's another big thing that we're currently seeing. And really, there's rarely an either/or scenario these days. I'm getting a little bit of feedback. Not sure.
Here, I'll go on mute. Also, someone
mute.
said the video is not showing for them. If you could refresh your screen, that might be helpful. But I'm going to go on mute. Pete, if you could do that too. Great.
Okay. So in any case, the point is there's a huge mix match of technologies and methodologies that are taking place all at the same time, which is, I guess, why we term this the hybrid cloud. It's really hybrid in many ways. And the goal is really to get a development and delivery mechanism that provides a cloud-like experience. Okay, so really, I think it's no wonder that we see a lot of emphasis on building cloud-native environments. We're not talking about one or two clusters either, nor are we talking about Kubernetes clusters just being used in some corner cases for testing out a proof of concept, for example. But today, more than a quarter of the companies surveyed by the CNCF last year said that they're using more than 10 clusters in production. And they're using multiple clouds, and they're adopting DevSecOps principles for modern app development. And then we see that people are encountering a lot of challenges because of doing that. In a hybrid cloud world, it's difficult to take all of these things into consideration. They might have distributed teams with diverse skills. They may be using different development tools or different versions of those tools, and they can find it difficult to collaborate across those lines. At the same time, companies have to keep pace with customer expectations. As industries are changing, customers expect more from companies. Heck, I'll just share with you, like last Friday, I got a new grill. And after my friend and I put it together, it took 3 hours and a couple of beers, but we put the grill together. I downloaded this cool app. I stuck the meat probe into the steak, and my phone told me when to use the searing function, when to flip it, when dinner was ready. Oh, heck, I'm not going back to caveman style grilling, but that's what's going on at a larger scale, right? Customers are expecting more, and this means that application teams need to be ready to develop, test, deploy new features as quickly and efficiently as possible. This is a recurring theme, right? It's about consistency. No matter what time of day, where you live in the world, or whether you develop software locally or in the cloud, development teams have to have access to production quality data to build the most efficient and up-to-date features. Likewise, I think the infrastructure blueprint is becoming more complicated. Not a lot of organizations realize that they're actually building out a hybrid multi-cloud environment until they're there, right? So they get on this treadmill, and then next thing you know, they have this huge hybrid multi-cloud environment. So making your data sets available to development teams no matter where they need to code means that infrastructure teams are constantly challenged to deliver consistency across a wide variety of platforms.
It's interesting,
then,
Michael.
Yeah.
There's research out there that says, somewhere between 80 and 90% of enterprise applications will be cloud native by 2025. And that seems like a mind-boggling number because there's lots of applications out there that need to be modernized. I guess you got to keep in mind, though, that when somebody says it's a cloud native application, it could just mean a lift and shift where they just took the app and are running it, on the cloud. But there's the other end of the spectrum too, where you go full on, you go through the 12-step process to rewrite your applications to really take advantage of, these new architectures. And what's interesting is there's also research out there that says upwards of 70% of these projects, to modernize these applications fail. And it's really interesting. And if you take a step back, a lot of what you're talking about, a lot of the complexity in the infrastructure and all these different apps at different states written with different languages, it is challenging, but there's also another challenge too, that I think a lot of people don't necessarily understand the paradigm change or the paradigm shift. As you think about Kubernetes, what we're talking about here today, it is a fundamental shift in how you develop your applications and how you run your applications. And, a lot of people dip their toe in the water and then they have a bad experience and they say, oh, no, I can't do that. But the reality is, with a little bit of knowledge about how these architectures work, you can really unlock the power that they present.
Yeah, and I do have a slide in here too that talks a little bit about what one of the strategies that folks can take to not just lift and shift, but over time build that modernization strategy. So we're going to talk a little bit more about that. But this is what you said, Pete. All great points. And at the end of the day, with all of these Kubernetes clusters, moving workloads from development to production, a lot of multiple fit-for-purpose type clusters being deployed for CI/CD pipelines and such. A lot of this, with all of these Kubernetes clusters out there, it becomes very unruly without, a centralized, consistent multi-cluster lifecycle management, without security, image scanning, things that really fill out the promise of Kubernetes, right? And then you have to be able to support security and compliance at scale, so security becomes a huge point as well. So, I think to that point, what organizations are seeing is, just being able to deliver all of these things in a multi-cluster environment, and being able to deal with things that typically were already taken care of in a typical traditional deployment, things like disaster recovery and high availability, and looking at things like CapEx cost reduction, and moving things to more of an operationalized workflow. And we'll talk a little bit more about each of these things. But one thing, and I think I brought this up in our last conversation back in July, but just to that point, what organizations are doing with containers these days, you can see the adoption rates for workloads like databases, artificial intelligence, machine learning, data analytics, in a containerized environment. They're all on the rise, and these applications are stateful, they're diverse. So once again, having a multi-protocol persistent storage layer built with Kubernetes services is essential for these things to take place. All right, so then what should be included in a modern application platform deployment? Well, first of all, it needs to support not just day one, day two operations, but day zero planning as well. So you have to be able to support your day zero, day one, day two operations, and it should be a single platform that supports dev, ops, and security teams, and they all have a consistency of use across that platform. I would say also organizations need a consistent user experience management and security across a hybrid infrastructure. So this provides that consistency layer and a uniform interface for administrators and users, regardless of the underlying infrastructure, whether it's on-premise or in the cloud, or even on the edge. And as a result, teams can both focus on innovation. That's what they do. That's what their job category is about, right? And you need a comprehensive tool set for cloud-native application development, as well as a built-in security across the entire application lifecycle. And finally, an end-to-end management plane provides that observability and applies consistent operational policies for security, configuration, compliance, governance, all for multiple clusters and across all these different deployment topologies. Okay, I kind of love this slide. Just to put things into context, the development platform is not Kubernetes. You see Kubernetes is sitting over there on the left hand of the slide there. Kubernetes is, of course, at the foundation, but it's the orchestration platform for containers. The thing I love about this slide is that it brings together so many of those projects and services that are really necessary to build out the platform. So you've got things like Grafana and Prometheus for metrics and monitoring, and let's say Quay for registry, and Elasticsearch, and Knative for serverless functions, Tekton and Jenkins for pipelines, Argo CD for GitOps. All of these things pulled together. These are all the projects that go into a container platform that makes it really useful and fulfills that full promise that Kubernetes really began. And since we were talking, this was what I was mentioning earlier, Pete. Since we're talking about all the application modernization, the question really comes down to when and which applications should I move, and then how do I do it, right? So you mentioned, people just lift and shift traditional applications over and call it cloud native. Well, that's not really cloud native, right? It's just a lift and shift. But there was a project on that previous slide called KubeVirt, right? And KubeVirt, remember how we talked about a lot of companies who still have virtual machines in their environment. Maybe they're deploying Kubernetes on top of VMs, but then some are trying to move to bare metal implementations and avoid VMs altogether. Well, virtual machines are really good in a lot of instances, say, for example, for running your existing applications, but what KubeVirt does is it allows you to run those applications in virtual machines on top of containers instead of the other way around. And this really offers a lot of flexibility to those who are adopting a modern application development approach while still maintaining existing applications. So, first you can rehost those traditional apps within your VMs on top of Kubernetes, pretty much that lift and shift approach that Pete mentioned. You can even run Windows applications in Windows virtual machines within the environment. And while you're building new applications and microservices, you can begin to re-architect your integration points across your application workflows. And then when the time's right, then you can rebuild that functionality and retire the old application, as opposed to, going out there and trying to recreate everything on day one. This approach is a lot less painful than just jumping and re-architecting everything for cloud native on day one. This allows you to take a stepwise approach and do what's right for your organization when it's right. Okay, and so then, remember we were talking about how customers' expectations keep growing. My little side rant about my grill, right? Well, is it any wonder that companies who are focused on their customers are adopting new technologies a lot quicker than their competition? But, one thing I thought was really interesting from this slide and the underlying report, is, IDC is forecasting that there's going to be an 800% increase in the number of applications deployed at the edge. And, for a lot of organizations, being able to gather and process that data closer to data sources in combination with new technologies like AI and ML, or new immersive applications can help to really build differentiation for their company. And by doing so, organizations can react faster, connect everything, anywhere, and deliver better experiences and business outcomes. Essentially, they're able to use the data that's derived from sensors and videos and devices, other edge devices, to make faster data-driven decisions at that point of inception, and deploy latency-sensitive applications with the experience that users expect, no matter where they are. So keeping that data within geographical boundaries also is important to a lot of times to meet regulatory requirements on data storage and processing. And then alongside the business drivers mentioned above, a lot of organizations also benefit from edge computing, as it helps to limit the data that needs to be sent to the cloud for processing, decreasing the bandwidth usage and costs, as well as creating resilient sites that can continue to operate even if the connection to the core data center or cloud goes away. And then you're also able to optimize resource usage and costs as only necessary services and functionality are deployed to address a particular use case or a problem that you're having.
So, Michael, I'm going to interject for a second. And I can only imagine the people that are in the audience, the slide you had a couple of slides ago with all the logos on it, and they go, oh my gosh, that's a lot of stuff. How do I figure all that out?
Right.
And, I think this kind of goes back to my earlier comment about, how many projects succeed versus how many fail. And, open source, and I'd love to hear your thoughts on this too, but, open source is great in that it's open, and it's readily available for people to use. But, oftentimes it's a challenge to figure out, well, I need this component, I need KubeVirt now, or I need this other component like Elasticsearch, and like putting those together in a solution. And I think that's where, the commercial space, is stepping in to help people understand, how do you put these together in the right combinations and making sure that they're going to work ahead of time. There's certainly complexity here for sure. I don't think anybody can argue that. And, it seems to fly in the face of what people are looking for, on the previous slide where you talked about, organizations that if they don't do this, they'll become the dinosaurs, so you're kind of stuck, like you have to do this. But I think the good news is there's a lot of commercial providers out there of this type of technology that can help you figure this out. You don't have to do it yourself. You can if you want to, but, it's a lot of projects to understand.
Yeah, well, exactly. I mean, open source software is free, right? Except that you need the expertise and you need the people to go out and build it and do all the investigation into which projects to bring in, how to harden those projects, what services do you need for, all of these different aspects of your deployment. And that's the thing. Going with a commercialized Kubernetes-based platform, right, brings into effect all of these other satellite services and components that are required to deliver that full experience. Now, like you said, you want to do it on your own? Sure, you can do it on your own, but is your core competence building a Kubernetes infrastructure? Or is your core competence building applications and building services to deliver to your particular customers, right? That's your core competence. These tools are what you want to use to get there. And certainly, anything from, there's commercially available cloud deployments of Kubernetes, right? So you could get started there. But then there's also, other commercial deployments of a Kubernetes-based platform that can, span from not just one cloud provider, but across its multi-cloud environment, as well as, on-premise and out to the edge, right? Okay, so, as we're going back to the discussion about edge, looking at an edge architecture, how do you become successful at developing this edge architecture? There's a lot of considerations there as well. For example, scale. Edge deployments can range from hundreds to hundreds of thousands of nodes or clusters. And it's not just about the infrastructure needed to support it, but also about how to ensure that the applications that you're building and deploying and running are done so consistently. Going back to that consistency statement, right? And location, of course. Edge sites can vary in physical size as well as in available on-site hardware and software. Network connectivity back to the central data center or out to the cloud, and power and cooling capabilities may be constrained quite a bit in different locations. Even within the same organization, making it hard to standardize on a single type of edge stack and the associated capabilities of that. And then people, on the people side, right? Edge sites vary in not only in their environmental perspective, but also in the available staff that you have to manage those environments. So, some locations may have very few or even no staff on site, IT staff on site to handle these things. So, leaving centralized resources to manage all of these sites is kind of impossible. So that can also be a challenge to resourcing teams to be able to manage all of the deployments on-premise, cloud, edge, et cetera, as you're building out your human resources, right? And then from a security perspective, you're out of that comfort zone of the data center. And edge sites are distributed and they lack a lot of times the security that's often found in the centralized environments. So how do you address all of these things? And then also, oops, sorry, one too far. Also, when we're talking about edge, what exactly do we mean by edge? Because, you talk about edge to different people, it means different things to different people. So, you see things like the provider edge, what we describe as a provider edge, for example, that might include things like telecom edge and centralized cloud edge, focused on things like telecommunication service providers. They need more of a reliable, low latency network with computing environments close to their mobile or fixed users. And then at the enterprise edge, if we move a little bit further out, right, this might be the core enterprise data store in a data center or as a cloud resource where customers extend application services to remote locations. Now, this you can typically think of like in retail as stores or restaurants, branch offices, transit stations, maybe in industry or manufacturing, factories, other types of remote locations. And then at the device edge, customers want to run edge computing workloads to field deployed devices like IoT gateways and drones and sensors and cameras, maybe point of sale terminals like for restaurants and retail, robots in manufacturing, for example. Now, for performance or latency reasons, the focus is really on gathering, processing, and acting on the data. For example, like analyzing inputs in real time from IoT sensors or cameras, for example, in order to provide immediate decisions or compute or preventative maintenance, prediction to drive data-driven decision-making and actions in real time, right? And even here, we're starting to see Kubernetes distributions. We saw the Microshift project essentially extending Kubernetes services out even further and delivering that common experience from cloud to core to edge all the way out now to device edge. And then I want to bring up distributed event-driven architectures too. Now, this is something that I kind of hold dear to my heart. I've been working with teams within my company that have built solution patterns and now validated patterns, et cetera, that really focus on taking these distributed architectures, right? So it's not just it's not just your storage, it's not just your data streaming. It's being able to build all of that together with different components and making sure they all run, and they're event driven. So they use things like Knative or serverless functions to be able to go and spawn off applications within that architecture, all at the same time, and they all interact together. Now, being able to build these event architectures and take that configuration, or what used to be, say, a reference architecture for a workflow, and building all of that as code, and then being able to operationalize that code and pull it together and then introduce things like CI/CD pipelines so that it's reproducible, it's extensible, and it has a software life cycle so that you're sure that as you continue to deploy this thing, that you're able to extend this out to multiple locations and it's repeatable. This all helps you go from a proof of concept to production on day one. I bring up here, and when you get the slides, there's you can go, or you can just type this into your browser, hybrid-cloud-patterns.io. There's a number of patterns that we've been working on, validated patterns and solution patterns that are out there that you can go out, you can take those, you can fork them, contribute them to them, or fork them and create something of your own so that you can use them in your environment. And this really helps to jumpstart a lot of these event-driven architectures that are out there. So, with that, I think we can move into the panel discussion.
Yeah. Wow. Thank you so much to both of you. That was a great overview. I have not seen any questions coming in. So please send in questions. We really are eager to answer questions. But I think let's transition now over to the discussion topics. So in terms of trends, where is Kubernetes going in the next few years? And Pete, do you want to start on that one?
Sure. Yeah. And, it's an interesting conversation because, Kubernetes is not a new concept anymore. It's been around a while, and, we've moved from, at least what I've noticed in the industry, is we've moved from the world of, very large organizations, like Michael and I were talking about earlier around, the complexity and who are the people that can afford to, invest their staffing and resources to go out and investigate all these projects, let alone like work with commercial distributions. We're moving from that world where it's kind of what I characterize as the tip of the iceberg into more broad scale applicability for, smaller organizations that maybe don't have those kinds of resources. And, I've always had a belief that, if you're not taking advantage of these cloud native technologies coupled together, and the undertone in Michael's presentation also was that the data is important here. If you're not taking advantage of these cloud native architectures and being smart about the data that your business generates, then you're going to be left behind in the dust. And so we're seeing that as the trend, that these solutions that we're talking about are becoming very mature. And we're seeing advanced topics like how do you do multi-site disaster recovery become common everyday talking points now, because as people move their critical applications to these architectures, these are the questions that are starting to come up. And the good news is that there's starting to be some very robust and very mature solutions in the marketplace to address those kinds of needs. So, I believe in the next 1 to 3 years, Kubernetes in general is going to continue the forward march. And it's interesting because there's even a lot of debate in the industry about, well, is Kubernetes just another one of those open source projects that's going to die, and we have to figure out how we're going to replace it. I don't think so. I think it's here to stay. It's going to be a major significant part of every organization's infrastructure. But Michael, I'd love to hear your thoughts on this too.
So Pete, I hope it's me and not and not you, because I missed about half of what you said at the end there. Michael, did you hear him okay?
Yeah, I did. Yeah.
Okay, good, excellent. So I'm going to agree vehemently with everything you said. How's that, Pete?
Good answer.
Okay. Okay, that's awesome. Thank you. So as far as the repatriation from the cloud, how much of that is actually happening? Because hyperscalers are still growing. What's the reality here?
Yeah, and hopefully my connection is fine when I'm speaking. But sorry, I missed what Pete was saying earlier. But I think I've seen a lot of different perspectives on repatriation from the cloud. I was actually talking a couple of weeks ago with some of our hardware value-added resellers, and they were of the opinion that it's happening quite a bit. A lot of their customers had an initiative to move everything to the cloud, and then the company was merged or acquired, or somebody took a look at the costs, and sure, they moved expenses from CapEx to OpEx, but then there were these runaway projects with little accountability, expanding costs, and so they started moving everything back from the cloud to the core data center. And I sort of think those situations do exist. But also I think that maybe the perspective was skewed a little bit because I was talking to hardware resellers. But I think overall the reality, and this seems to be the consensus out there, reality of the situation is that where applications run is really more workload dependent, and we continue to see workloads moving from public clouds, and at the same time, some workloads are being repatriated. So let's take, for example, a workload that might need processor accelerators like GPUs or even deep learning accelerators for a short period of time. It would make sense to offload some of that work into a public cloud deployment, because the analysts or the data scientists could run the majority of their model on less expensive hardware and then burst out to the cloud for the resources that they need when they need them. In this way, the organization can save money by not making capital purchases for the resources that will largely just remain idle. But at the same time, a lot of data is restricted or governed and can't live outside of a corporate firewall. So in fact, like if you go to Europe, many countries around the world even restrict companies within their borders from housing data on servers that are outside of the country domain. Now, these workloads are clearly being repatriated to the data center. And a lot of other factors, such as costs and data gravity, will also contribute to some of these workloads being repatriated. I would just say, like, another big trend that we're seeing today, as well as the proliferation of workloads to the edge that we discussed, in some cases, these edge deployments are connected and they can interact with cloud resources. And others, they're disconnected, either because they don't have access to the network, they have spotty access to the network, or due to security restrictions. Think typically, of big government deployments and things like that, right? So the positive light to all of this is, I think this ongoing transformation includes hybrid and multi-cloud deployments, as well as edge computing that's in Kubernetes. And these can all offer a common experience across all of these underlying infrastructures. Even as far out as the edge, device edge now, as we saw with Microchip, there's this abstraction from the underlying infrastructure, so users of the resources have a consistent experience. I don't know, Pete, if you've seen what your thoughts are on cloud repatriation as well.
Yeah, and I'm going to take the conversation in a little bit different direction. Everything you said, I completely agree with, and we see this also with the organizations we work with. The other aspect of this too is, one of the nice things, and this is kind of in direct contradiction to what we were talking about earlier, is it's very easy to consume these services, particularly in a public cloud context. All you need is a credit card, right? And so what it's given birth to is this age-old term of shadow IT. And organizations are aware of this, primarily because they're getting smart about their cloud spend, and they're starting to aggregate it, and then they're realizing, wow, we're spending a lot more than we really imagined that we had been spending on public cloud. And in fact, we're probably spending more than if we would have kept our on-prem data centers. But a lot of organizations are saying there's no way we're going to go back to on-prem and the capital expense associated with on-prem data centers. So I think you have a little bit of that effect going too, where line of businesses are taking more control of these types of things, because it makes sense. If you talk about applications and talk about data, they really should own, the data, because they're the smartest about the business and their customers and understanding them. But at the same time, I think what organizations are realizing is there's got to be a balancing act between these two. And, it's great that app developers have ready and quick access to public cloud services. But then, to your point, as you scale it into production, what does that look like? And particularly from a cost perspective, these are things that organizations are putting under the magnifying glass. So I do think cloud repatriation is a thing, but I do think there's a lot of momentum in the space right now. And, we'll continue to see more and more applications coming to all of these types of platforms, not just public cloud, but on-prem and certainly edge too, as you've been talking about.
Okay.
Yeah, and that's the point.
Yeah.
I think it's happening in all across the board, right? We see growth in cloud deployments, but we also see repatriation of certain workloads back to the core data center.
Yeah, that's great. Hey, we have 2 questions from the audience, and so if we could quickly touch on these quickly, and I think our time is pretty good, but we may want to increase the pace a little bit too. So the first question is, should we assume that 76% of databases have larger cache and are stateful container? Do they use stateful container use cases?
Yeah. So I'm reading that. So should we assume that the 76% for databases and data cache that came out of that survey earlier, are they larger stateful container use cases? And I would say yes. Yeah. Pretty for the first part, they are stateful. I mean, it's a stateful workload. Are they larger deployments? Well, they could be. It depends on what those databases or data cache services are doing, right? But you can start to build smaller application sets that use a database on the back end, right? And depending on the size of that particular application and how it fits into a workflow, it may be larger, it may be smaller, but certainly it will be stateful.
Yeah, and I think, Michael, I think you would agree with us too, that we see this as probably one of the leading use cases for Kubernetes platforms right now, as databases and analytics types workloads sitting on top of Kubernetes.
Great. And then we may not be able to answer all the elements of the question, but if we could give a quick estimate of the percent of rehost, refactor, re-architect, and maybe a flavor of what drives those decisions. And we'll have more time to spend on the blog when we do the Q&A. So.
Yeah, I can't say that I really know what people are doing, what percentage of each of those functions people are doing. But the slide I brought up was really to let people know that there's that option, right? That they don't have to, because I think the question kind of goes back to, all right, so if I have a directive from my corporate executives to go out and modernize my applications. Okay, go and modernize the applications. All right, great. So I have to take all of these existing apps and I have to maintain them because they're still, germane to running my business, and I have to modernize them at the same time. At the same time, I have all of these other people's line of business managers who are saying, "Hey, I need new apps," right? So it's kind of like, all right, so how do I do that? And the slide was really to talk about how do organizations, how are they able to manage all of that at the same time? And so I think it's a question of, what does each of the applications or the traditional applications that you have, existing applications that you have, what do they serve in your business? You can quickly lift and shift them over to a cloud native infrastructure or a containers infrastructure, rehost, right? But at the same time, by doing that, you can start to formulate your strategy as to when you want to refactor, re-architect, and redeploy new services to take the place of those. I'm not really sure what the percentage of each of those steps are right now, but it's a good option to have as you're trying to plan out that application modernization strategy.
Oh, that's great. So on the next question, the industry has recently seen new Kubernetes related reference architectures coming from traditional hardware vendors. So what differentiation is possible using Kubernetes on industry standard hardware?
Yeah, I think this is something we continue to see unfold over time, but certainly as we see Kubernetes platforms starting to take place, starting to take over, that traditional virtual machine space, I think there's a lot of interest in building architectures to support it. Now, that said, right now, there's a lot of hardware vendors that are starting to make their bets on what segments to go after. For example, HPE has a compact mode deployment built on their Edgeline 8000 servers targeted at public sector deployments. They also have a AI accelerator product that they built with NVIDIA GPUs. Dell has a long history of building validated designs with Kubernetes platforms. And now they have specific designs for telco, as well as multi-access edge computing. And, just 2 months ago, they released a new validated platform built on their PowerFlex systems as well to build a tighter engineering effort with Red Hat around their OpenShift platform, right? Likewise, we see companies like Cisco they've just released a validated design for Kubernetes running on their UCSX platforms. Supermicro, for example, is designing an AI platform with Intel that incorporates the Intel AI toolkit, OpenVINO, Converge.io, and even the Habana deep learning accelerators, all running in a Kubernetes platform. Now, while the platform architectures and the target workloads or the market segments, they're really interesting right now. Another emerging trend we see is for hardware companies to kind of reinvent themselves, to offer a full managed service offering to customers built on Kubernetes. And we've seen this recently with announcements from HPE again around their GreenLake offering, and then more recently from the Dell Apex team, right? Full-scale hardware providers, they've also amassed quite a bit of experience in Kubernetes, and they have a complete services arm that can go out and provide managed services, not just for the infrastructure, but also for the Kubernetes-based platform, in addition to the overall infrastructure services that they typically offered before.
So that really addresses the complexity that you talked about earlier, right? So they're bringing the services to address some of the complexity.
Yes, exactly. Because a lot of the existing hardware manufacturers, they also have financing options. They've redesigned some of those financing options so customers can purchase the service as a utility. So they really get that cloud experience, that overall cloud experience, as well as the ability to operationalize their costs over time.
It's interesting. There's a philosophical part to this too. I mean, if you think about Kubernetes and the notion of an application can now consist of tens, hundreds, even thousands of microservices, you're really, cutting and chopping, your applications up in these microservices can be run anywhere. So what implication does that have? What I think we're starting to see is a movement away from monolithic architectures. And I know the buzzword right now in the industry is disaggregation. And I think it's true. I think we are moving towards a world, and a lot of this is copying what the public cloud hyperscalers have already figured out in disaggregated architectures is, the ability to expand and grow independent components on the fly. I mean, that fits really well with the whole Kubernetes context. So I think we're moving from a world of monolithic traditional architectures to much more disaggregated architectures.
Okay, that's awesome. Thank you. Thank you both. And for this question, could you help parse the meaning of hybrid cloud versus distributed cloud, particularly as it relates to current industry trends, just to understand where the data lives?
Yeah, it's an interesting question. And, hybrid cloud has become one of those terms, I think, that is overloaded in the industry and everybody uses it. And I think a lot of times means different things to different people. I think there's this notion, that with Kubernetes, I can run my applications, my pods, and my microservices anywhere. But the reality is that's not what people do. More often what happens is, an application has a set of data that it is accessing, and those are co-located, on some sort of a platform, be it a public cloud platform or an on-prem or even at the edge. So when we talk about hybrid cloud, it's kind of goes back to what Michael said at the beginning of the presentation, that you have all of these different environments just by virtue of the way things have evolved. And you didn't necessarily set out with that as an objective or a goal in mind, but you ended up there. And so when we talk about hybrid cloud, multi-cloud, distributed cloud, that's really what we're talking about, is the capability to manage these applications across all of those, not necessarily running those applications simultaneously across those different platforms, more so managing multiple different applications in these different environments.
Great.
Yeah, and I was out at a conference, like, it was a long time ago, so I don't remember where I heard it, and I hope they didn't, like, trademark it or anything. But somebody some time ago said, "Cloud is not a where, cloud is a how," right? And really, I think when we talk about hybrid cloud, right, we're talking about the how. It's that experience. It's having the ability for a user or a developer or a data scientist to go out there and be able to take the resources they need to get their job done, right, without having to go and file a ticket or have a huge project in place that is being managed across the organization, right? They just go into the platform and they're able to get the resources that they need, spin up the resources, use them as they need them, and they have that common experience. So if they're running it and that infrastructure happens to be in-house in the data center, or that infrastructure happens to be out on AWS or a smaller managed service provider, right? It doesn't matter because they have that common experience across all of that. So that's where we start to talk about hybrid cloud. It's not the where, it's the how.
Yeah. Okay, awesome. We've got 2 questions left, and so if we could briefly touch on each of these. So as far as emerging workloads, how are edge computing architectures taking advantage of the data in Kubernetes?
I mean, Michael, you gave a great example there, that last slide in your presentation about the patterns. And this kind of ties to the very first question here about the trends that we're seeing. Again, the maturity of this market, and now looking at more turnkey solutions built on top of the Kubernetes infrastructure, things that solve and automate, because that's the other aspect of Kubernetes, is automate the heck out of everything, right? So as Michael was talking about, these architectures where you can ingest data at the edge, process it a little bit at the edge if you want to do that, but also ship it off to a core location where maybe you have more expensive, GPU resources that you want to do deep learning. And so we're starting to see those kinds of architectures that are driven by automation so that it's hands-off, data is processed, automatically, and you get insights from the data much, much more quickly.
Mm-hmm. Yeah, I kind of go back to I like where you're going with that, Pete, and I think it kind of builds into those patterns because I mentioned the solution patterns or the validated patterns as this automated workflow, but one of the things I didn't really bring up is that it's extensible. It's extensible to the edge, So, for example, if you went and you looked at that GitHub repo, you'd see things like an industry 4.0 deployment, right? So being able to deploy that out to multiple factory sites. Another thing that sometimes I like to bring up too, and this kind of like dovetails into what we were talking about with Intel earlier and some of their products, right? Is the ability to, like, let's say you're doing offshore oil and gas discovery, right? In that type of deployment, you're shooting a sonic wave down to the ocean floor, it's coming back up, and you have all these sensors out there in the sea that are collecting that data. Typically what happens is all that data gets gathered back, it gets sent to the core data center for processing. And at that point in time, you find out whether or not you got good data. If you can take that and run some analytics across that data as it's being collected, you can see whether or not you have corrupted data, and you can go back and re-sweep that area that was corrupted, untangle your devices and go out there and re-sweep without having to go back and find out later that you just wasted all this time and money. Right, so things like that, and I see we're kind of running out of time, so I won't go into too much more. But in any case,
yeah, sounds great. So thank you so much. So for the last question, just real brief, what challenges still need to be solved? And we could certainly add more in the Q&A blog. So.
Yeah, I kind of see that. Yeah, and this is a progression. Like the past few years, we've seen this huge adoption of Kubernetes. We've seen it move from, hey, we're just taking it and we're fooling around with it, we might be creating some stateless apps and stuff, to full scale enterprise application deployments. And I see that as continuing that trend, and to the fact of, going back to edge, being able to deploy out now to the device edge with Microshift, right? All of these things continue to develop. I think what we'll see is more and more of these projects that, that big slide with all the logos on it, more and more of these projects being uncovered and hardened and brought into commercial platforms to really address some of the other services aspects that we'll see from progressive application development and deployments. Yep.
Great. Pete, 15 seconds.
Yeah. So I mean, it goes back to what we were talking about earlier. Is the state of any application? It may be running on bare metal, virtualized, or cloud native. And to me, this is one of the big challenges that needs to be solved right now, is how can you more effectively support that kind of environment? We have a lot of these things today, like you can run Kubernetes on top of virtualized platforms. You can run virtualized platforms on top of Kubernetes. So there's already been a lot of good work that's been done there. But in terms of refactoring applications, I mean, the state of affairs today is it's a 12-step process, and it's time consuming to rewrite your applications. So if there's any challenges to solve, it would be making it much easier, to go between these different environments and to port applications.
Okay. Okay. We are over time briefly, but I just wanted to thank you both for the amazing, fantastic information. Thank you so much for your time and effort to put in that you put into this. And thank you also to the audience. Thanks for joining us. Please remember to rate this webinar, as this is very important for feedback that we can make better educational material. Please also remember you can download all of this material and more at our educational library, and follow us on Twitter. Thanks to everyone. We really appreciate your attendance. Thank you. Bye-bye.
Thanks.